Hey, and welcome to this quick educational video on dimensional analysis. My name is Megan McDowell, and I already covered one-factor dimensional analysis in an earlier video. So if you haven't already watched that one, please go back, where I explain what dimensional analysis is and how to do it in relationship to nursing and Med-calc problems. So to continue with two-step and three-step, the steps of dimensional analysis remain the same. We are going to identify what's the given quantity or the order. You're going to figure out where you're going and figure out what is the wanted quantity of the problem. You establish the unit path, you set up the problem, you multiply numerators and denominators, and then you divide to get the numerical value of that wanted quantity. So I'll give you a couple practice problems where we'll bring this to life. In my previous video, I went over some conversions that I require my students to know. These are pretty common ones that you're going to see in the hospital and clinical. So I recommend either printing these, keep them on a clipboard or commit them to memory. So the only difference with two-factor and three-factor is that now you may have a two-factor numerator in your given quantity or even in your wanted quantity. So instead of just having one, you may have two. So for example, I'm going to go through some problems with you that we can practice together so that you can see what I mean. So this would be a two-factor problem. So the order is 2 milligrams per kilogram. So that's where the two-factor comes in. So now we have both milligrams and kilograms in terms of our given quantity. Okay, so our wanted quantity in this one is milliliters. The question's asking you, how many milliliters will you give to ensure that this is the correct dose for your patient? Now we'll have some converting to do. So we can see on hand that you've got 10 milligrams per milliliter in your it's an oral solution, so probably liquid, and that you also have a weight to convert. Okay, so let's get started. I recommend setting it up in this way, creating this path like this so that you can see where you're at, where we're going, and that sort of thing. So I'm going to zoom out just a little bit so you can see what we're doing here. So step one of dimensional analysis is always to set your given quantity or your order in this situation. Your order in this one is 2 milligrams, forgive my chicken scratch, per kilogram. Okay, and you can see that I put milligrams on top and kilograms on the bottom, so numerator and denominator. Now the next step is, where are we going? So we want to figure out how many milliliters are we going to give this patient, okay? So we can see right now from the get-go, we don't have anything that matches where we're going. So we have some conversions to do to get wherever quantity that we want that's correct. So I can see on hand, I have a little container of furosemide, which is Lasix, that's 10 milligrams per 1 milliliter. Now you remember in a previous video, to get rid of your unwanted quantities, you have to have them adjacent to each other. So we're going to put 10 milligrams in the denominator so that we can get rid of our milligrams. And we're going to put 1 milliliter up top. Now, I always encourage my students, bring a highlighter, bring a different colored pen or pencil so that you can see. As soon as you get what you want, which is where we're going, go ahead and circle it, okay? Because we know that that's what we need to end up with. Now, you'll see we still have kilograms out there, so that means there's still some conversions to do. In this problem, I've given you that the child weighs 10 kilograms. So that will have to be put up top so that we can eliminate kilograms and kilograms. And now we can see we've eliminated all of our unwanted quantities and we have what we need, which is milliliters. For this question, now you're going to multiply your numerators, you're going to multiply your denominators, and then divide your numerators by your denominators. So 2 times 1 is 2, and then obviously 2 times 10 is 20. Okay, so we're going to get 20 up top, and then 1 kilogram times 10 is just 10. Okay, so now all we have to do is divide 20 by 10, which will give us 2 milliliters. Okay, so that will ensure that based on this child's weight, we're giving the correct dose for that child. Hopefully that makes sense. We're going to do a couple more. So for this next question, you've got heparin, which is a blood thinner. The provider orders heparin to infuse at 1,300 units per hour, okay? The pharmacy sends you as a nurse a bag that's labeled 25,000 units and 250 mLs. And they're asking us, how many milliliters per hour should we set that IV pump to ensure that the dose is 1,300 units per hour, okay? So let's start by setting it up with the given quantity or the order, which is 1,300 100, not 1,000. And for units, remember that's not one that we can write U for. You actually have to write it out. And that's one of those unapproved abbreviations. We always want to write out units, not abbreviate that. And then that was 1,300 units per 1 hour. Okay, so if you like to put a 1 as a placeholder, you absolutely can. You're not required to. You can just write hour underneath. Now for this one, we're wondering how many milliliters per hour should we set the pump at to ensure that we're giving the correct dose, okay? Now, with this being a two-factor, so you can see we've got two factors in our given quantity. We have units an hour, and we're also going to have two quantities in our unit. We have milliliters per hour. So that's why it's so critical to set this up correctly, that you have milliliters in the top or the numerator, and then hours in below in the denominator. Because if you don't, it'll screw up your numbers, which will screw up your dose, and potentially you're giving the wrong dose of heparin to your patient. Okay, what do you notice about this? I always tell my students, cross out or circle if they have anything. You already can tell, we already have hours. Okay, so that's wonderful, that matches. But we have units, which we don't want. We want milliliters. So now we're gonna have to enter in what pharmacy sent to us. Okay, so they sent us a bag that had 25, let's see if we can get the zeros in there if there's enough room. It had 25,000 units in a bag with 250, whoa, hard to write on this thing, milliliters. Okay, and setting it up that way with them adjacent to each other, we can now cross out units and I can circle milliliters. I don't want you guys to do any computations on your calculator until you have circled where you're going, because it doesn't make sense to until you're sure you have everything eliminated that you don't want and things are in the correct space so that you can see here it is. Okay, now with this one, we're dealing with some bigger numbers. So you absolutely can multiply 1,300 times 250 divided by 25,000. You will have bigger numbers, which sometimes is more room for error, margin for error on your calculator. So I do recommend, we have 3 zeros below and we have 3 zeros above. So if we get rid of these 3 zeros, we can get rid of 1, 2, 3 zeros up top. So then you would just do 13 times 25 divided by 25. Okay, hopefully that makes sense. I'm going to pull out my calculator and do this with y'all. I recommend that you have pen and paper and that you're doing this along at home. So 13 times 25, you should get 325, and we're going to divide that by 25. So if we do, we have a straight answer of 13 milliliters per hour. Okay, so hopefully that made some sense. Let's do another one. I love these ones. So a lot of times my nursing students, why do we have to figure out drips per minute or IVs? Well, sometimes, like I know with our hospital, sometimes if we're on bypass and have a lot of patients, we run out of enough IV pumps. You might need to be counting drops to ensure that a bag would infuse in the correct or the ordered time. This could be really important if you're taking care of a patient with heart failure or any type of renal involvement that we wouldn't want to give too much fluid too quickly to. So with this one, you'll have to know what your drip factor is of your IV tubing. So on this drip factor here, we can see this is the Alaris pump tubing, and it's a drip factor of 20 drips per milliliter. You'll need that information in order to be able to do this problem. Okay, so with this one, we have our order, 1,000 milliliters or 1 liter of D5W half normal saline with 20 MEQs of KCl. So it's got a little bit of potassium in it, and it's supposed to infuse over 12 hours with a drip factor of 20 drips per ml. Now it's asking us, how many drips per minute are we going to have to give? So I didn't do that, but the question is, how many drips, GTTs, per minute? Okay, so that's what we're trying to figure out so that we'll know that this bag infuses over 12 hours with this tubing with a drip factor of 20. Okay, so our given quantity in this one, or our order, is 1,000 milliliters. That's that bag. It's 1,000 mLs over 12 hours. Okay, now I gave you some extra information in this. I gave you a lot about what type of solution it is, how much potassium is. That's just extra. We don't need that for this problem. Okay, so it's one of this is probably trying to find extracting the information that's relevant from the problem, where that's just kind of extra fluff. Okay, so we have our given quantity. Now we need to know, where are we going? We're trying to figure out how many drips per minute would ensure that that bag infuses over 12 hours. Okay? So now we're going to do this in the sequential method, which means we're going to get rid of whatever we don't want in order. Okay? I like to do first with the hour part. So you know that in 1 hour, there's 60 minutes. Hopefully you know that. Okay? And by doing that, I can eliminate hours. And now look, my minutes match where I'm going. Go ahead and circle that. So you know you don't need to do any more conversions with that. However, I still have milliliters, right? Now is the fact where we put in our drip factor, which we said was 20 GTTs, which is drips, for 1 milliliter, okay? So the 1 milliliter has to go below, and then our 20 GTTs are going to go above. Okay, and what that allowed us to do is to get rid of those milliliters, and now you can circle your GTTs, and we have minutes. So now you're ready to do your calculations. If you want to, you can multiply 1,000 times 1 times 20, and then divide by 12 times 60. Or if you want to get rid of one of those zeros, we have 1 0 to get rid of. We can get rid of 1 0 there. So now it's just going to be 1,000 times 2, which we know is 2,000. Okay, and then we have 12 times 6, right? So if we all know what that is, that's going to be 72, right? I hope to carry the 172. This is why I encourage my students to use calculators. Okay, so now I'm going to use my calculator to divide 2,000 by 72. Okay, and we get as an answer 27.777 drips per minute. Okay, now I don't know about you, but I can't count 0.7 drips. So typically with any question like this, we're going to round to the nearest whole number. And since this number is greater than 5, it's going to go to 28 GTTs, or 28 drips per minute. And if you actually watch that, that will ensure that that bag of D5 half saline with 20 of K will go in over 12 hours. All right, hopefully you've got the 2-factor down. We're going to move on to 3-factor problems. The only difference with 3-factor is instead of having 2-factor in your numerator and denominator, you might have 3 factors in your denominator now. So for example, the order for this problem is Tagamet, 40 milligrams per kilogram per day, and that's divided in 4 doses. On hand, the supply you have is Tagamet 300 milligrams per 5 mLs. You have a child that weighs 80 pounds, and the question is asking you, how many milliliters per dose are you as the nurse going to give? So we're going to do this just like every other problem. Just start in order. Always talk like, be like Dory, you know, they keep swimming and swimming and swimming. We're going to be converting and converting. So bear with me. All right. Our order in this one, or our given quantity, is 40 milligrams per kilogram per day. Okay, and here's where we got that 3-factor from. You have milligrams, kilogram, and day all in your given quantity. Okay, now the question is asking you, how many milliliters will you be giving per dose to that child? Okay, so let's look to see what we have so far. We've got milligrams, we've got kilograms, and we've got day, and we have none of those matching. So we have a ton of converting to do. Okay, let's do what we've got. I like to kind of go sequentially in order. So let's put in what we have on hand first. So on hand, you have 300 milligrams in 5 milliliters, right? Okay, so now I can get rid of those milligrams. And look, now I have milliliters and it's in the correct spot. Go ahead and circle that, okay? So that's just what we needed. Now we still have kilograms and we still have day, so we're gonna have to get rid of that. Now if you look up, you have a weight in pounds, not kilograms. So remember, it's if you're overweight, sometimes people like to tell you their weight in kilograms over pounds because it's smaller, right? That's how I remember that. You can see that I put kilograms up top for the purpose of eliminating it, and pounds will be below, okay? Now I have pounds, and we're going to put in the child's weight, which was 80 pounds. 80 pounds. Okay, now I can eliminate those two. Okay, now some people don't like to leave this area blank. If you want to, you can put a 1 there. It doesn't change anything, but just know that you can eliminate the pounds, leave it blank, or put that 1 in if you like a placeholder. Completely up to you. It won't change anything. Okay, now we still have day. We don't want day, we want dose. In this problem, we told you that this child's getting the 40 milligrams per day in 4 doses. So that means in 1 day, that child is getting 4 doses. So we're going to put 1 day up top because we're asking you how many milliliters per dose if they're getting it 4 times a day. 1 day, they're getting 4 doses. Okay, I can now cross out my day and I can circle dose and it matches there. So now I've got milliliters that matches where my wanted quantity is and I have doses. Now you can go ahead and start doing your math. Okay, so this is where I really encourage my students to do the computations twice. I'd say the 2 most common things where I see my students get a little bit turned around on this is maybe not putting things in the correct numerator or denominator, and then also miscomputations. So punching in the wrong number or transferring over the wrong number. So always do it twice just to make sure. Okay, so we do have 2 zeros below. If you would like to, you may get rid of those 2. Remember, you have to do on top what you do on the bottom. So then it becomes 4 times 5 times 8, okay? And then you're going to divide that by 3 times 2.2 times 4. Okay, so I'll give you a second at home so that you can do that math, and we'll come back in a second once you have. All right, so for that one, if you got 6.1 milliliters per dose, you're correct. Milliliters per dose. And that child, remember, will get that 4 times in a day, but it just asked you in 1 dose how many milliliters. So 6.1. So that's the correct answer. All right, let's try another 3-factor one. Now this is dopamine, 20 micrograms, MCGs per kilogram per minute for a patient that's in cardiogenic shock. On hand, you've got that bag of dopamine that's 400 milligrams and 250 at 0.9 normal saline. Patient weighs 180 pounds. How many milliliters per hour are you going to set that pump? All right, so let's do this step by step. So the first thing we're to do is our given quantity, which is 20 mics per kilogram per minute. I want to show you if you have 3-factor, I always think of the 2 always go on the bottom. I think they're heavier, so heavier things tend to go down, right? They sink. So you always want to have the 2 underneath the 1. So mics will be on top, kilogram per minute will be on the bottom. It's heavier. Okay, now where are we going? We want to know, step 2 is how many milliliters per hour, okay? And if we look back, we don't have anything that matches. We have some converting to do, just like in the last problem. Now the difference with our last problem, we were in milligrams, now we have micrograms in milligrams. So I would like you, first of all, just to convert, okay? So in micrograms and milligrams, okay? So we know that 1 milligram is equivalent to 1,000 micrograms, okay? And in doing that, now we've eliminated mics. Now we can factor in what we have on hand, which is 400 milligrams. That's in that bag that pharmacy sent you, in 250 milliliters, right? Okay, now I can get rid of milligrams. And look, we've got milliliters. It's in the right spot. We're on the right track. We can go ahead and circle it. Now we still have kilograms and I have minutes, okay? Why don't we do the weight first if we're doing this in order? We have a weight in pounds. So step 1 is going to be converting kilograms to pounds, okay? Remember when you're converting kilograms to pounds, which one is bigger? Well, 1 kilogram is equivalent to 2.2 pounds. Okay, now we can get rid of kilograms. We can factor in that this patient weighs 180 pounds. So we have to put it up top so that we can eliminate it. Again, that was an 80. That's not a very pretty 8. There we go. You can put that one there as a placeholder if you'd like, or leave it blank, up to you. All right, the last thing that we have here that we need to get rid of is minutes, okay? Because we're looking to go to hours. So you and I both know 60 minutes are in 1 hour. And that should be our last conversion. Okay, so we can eliminate minutes and then we can circle hours. I can't tell you the importance of doing this crossing out and circling because it really not only gives you peace of mind that it matches, that it's in the right spot, but it really just kind of keeps you organized. And especially when you're doing 5 different conversions, sometimes more in these problems. All right, so for this one, we're going to multiply our numerators. We're going to multiply all of our denominators and then divide our numerator by our denominator answer. Okay, so for this one, if you did not eliminate anything, you would get something huge, like 54 million over 880,000, which is fine. If you wanted to eliminate some zeros, you can absolutely do that. I recommend doing 1 to 1 just to keep yourself on track. We have one over here we can get rid of. We've got one over here we can get rid of. And I think that's all the zeros we've got. Okay. So either way, you should end up with, looks like 61 milliliters per hour. I'm going to verify that. So if we did it the long way, not eliminating the zeros, you're going to get 54 million. That's a lot. Divided by 880,000. And you get 61.36 milliliters per hour. Now, some pumps can accommodate, if you wanted to round that up, 61.4. For this problem, I'll just have you round it to the closest whole number, which would be 61 milliliters. With my students, I typically tell them what I want them to round to, but otherwise go by your agency's guidelines. All right, one last problem before we leave. All right, so this problem, we've got Lasix or furosemide for heart failure. Okay, so that problem, the given quantity is 2 milligrams per kilogram per day. And remember, we're putting kilogram per day below. It weighs more, it's heavier, it falls down. And then we're asking how many milliliters per day are we going to give that patient? Okay, what do you notice already? You already have day. Awesome. So we can circle that. Okay. Now we have some other things that we need to get rid of. With the milligrams, we're going to put in what we have on hand, which is 10 milligrams per milliliter. Okay. For 1 ml. Now we can eliminate that. Okay, and look at, we've got milliliters in the correct spot, so we can circle that. Now we just have to factor in, we still have kilograms outstanding, and that's because we have to factor in the patient's weight. So for this one, I gave you a weight in kilograms. So I also have students that try to convert it to pounds back to kilograms. Don't do that, you already have it. So you just have to put in 40 kilograms. We're gonna eliminate and then eliminate. And now that we've crossed out all of our unwanted, we've circled what we wanted, and it matches our where we're going, we can go ahead and do that math. To make it easier on us, let's get rid of 1 0 here and 1 0 there to make it 2 times 1 times 4, which is 8. And we're going to divide that number by 1. So for that question, you should be getting 8 milliliters per day. That's your answer. So that's all I've got on 2 and 3 factor dimensional analysis Med-calc problems. I hope this video was helpful. Feel free to like and share and reach out if you have any questions.